So the best way to find the best line of best fit is if you were to draw that line and then you measure the distance that each of the points is away from the line. And that's just a straight distance up on the y-axis, not the straight distance to the line. Like this one, straight distance to the line would be like that, but just straight up and down. And then if you take all those distances, some of them will be above the line, some of them will be below the line. So we square them in order to make them all positive. And then if you added all those things up that were squared, you want that square number to be as small as possible, because then your line would be as close as possible. And that vertical distance is called the residual. So sometimes our point is above the line, then our residual would be positive. Sometimes it's below the line, sometimes it's on the line. And if we squared all of those and found the lowest possible sum, that would be the best line that fits through those data points. So here's where we have some crazy formulas for our slopes. They look pretty crazy. We've got some interesting notation. So here, your rise, you're going to look at the sum of all x times y values, and then you're going to subtract the sum of all x times the sum of all y values, divided by how many you have. And on the bottom, you're squaring that, so you're going to add up all your x values squared and subtract the sum of all your x values squared divided by n. So we're going to look at, oh, by the way, this is something we normally don't do by hand. Okay? So that's a good thing. But here is an example of a line. We're going to use the formula to find the equation of the regression line with those points. So we've got 1, 3, 3, 5, and 2, 1. So we've got a table here set up with those points. We've written down what xy is. We've written down what x squared is. And we've got our sum of all of our x values, the sum of all of our y values, the sum of all of our x times y values, and the sum of all of our x squared values. So if we take this data, and I copied and pasted it again there, here's our rise, and here's our run. If we plug it in, it's going to be the sum of all of our x, y values minus the sum of our x values times the sum of our y values divided by the number that we had, which was 3 points. And we get 2. And on the bottom, we're going to take the sum of all of our x squared, which is 14, minus the sum of all of our x's squared divided by 3. Subtract those, and we get 2 again. So we have the slope is equal to 1. Our mean point, the mean of our x values and the mean of our y values, is 2, 3. So we get our equation to be y equals x plus 1. So how do we do this with our calculator? So what we're going to do is we're going to put this in, these 3 points, into our calculator and see if we come up with the same line of best fit. So start by putting in your data into list 1 and list 2. After I went to Zoom 9 and got my points to show up on there, I noticed that I couldn't see my x-axis or my y-axis. So then I went to my window button And I noticed that my x-min was like 0.8. So I just changed it to -1 just so I could see my x-axis. You may like to see that just to feel like you can get a sense where your graph, otherwise your graph is a window sort of in the middle of nowhere with no reference points. And then it's got my 3 values there. Okay, so once you've got your data in there, going to go to Stat, Calculate. Stat over to Calculate, and then go down to number 4. Newer calculators will come up with this screen on the right. Older calculators will just have Lin regression show up, ax plus b in your screen, and then you just push enter. The newer calculator here allows you to store your regression line, and so if you type y1 into there, then it'll automatically put it into your y equals. If you don't have that, these are the buttons you'll need to push in order to get it into y1. So you'll go to your vars, go over to y vars, push enter on function,